Hey everyone, welcome to this explainer. Today, we're diving straight into a fascinating chapter called Double Century. It's all about that journey from our basic human instinct of just guessing how much stuff is in front of us, all the way to really understanding big, abstract numbers. It's a pretty brilliant progression, and we're going to unpack exactly how this builds mathematical confidence step by step. So here's our roadmap for today. We're going to cover the art of estimation, the story of numbers, making a perfect hundred, counting real objects, and finally, reaching the double century. Let's get right to it.
Part 1. The Art of Estimation.
Picture walking through a busy, vibrant market. Before any of us ever learned to sit down and formally count, we just guess, right? When a kid walks past baskets overflowing with oranges, rows of shiny bangles, or massive piles of sweet ladoos, their brain automatically tries to size it all up. This chapter taps directly into that raw visual intuition.
Actually, I want you to mentally play along for a second. If you glance at a pile of fruit, how close can you get to the actual number just by eyeballing it? This is absolutely crucial. It's the very first step in building number sense. You learn to trust your eyes and make a solid, educated guess before doing any rigorous counting. Moving on to part 2, the story of numbers. Now, to really appreciate why we count the way we do, the chapter takes us on this magnificent historical detour. We're talking tens of thousands of years ago, when humans were just making scratches on cave walls and tree bark to keep track of their stuff. Over time, that evolved into grouping things, making groups of 5, 10, 20, or even 60 to make counting a whole lot easier. But the real game changer, that happened thousands of years ago when ancient Indians created a way to write literally any number, no matter how huge, using just 10 simple symbols, 0 through 9.
And the absolute star of the show in this system? It's the number 0. Think about it. Introducing a symbol that literally means nothing, or the total absence of something, was totally revolutionary. It's the whole concept of 0 that makes this entire numeral system click together so perfectly. Without it, the whole idea of place value just falls apart. So here's the massive takeaway for you. This ancient mathematical tech, just these 10 little symbols, is the exact foundation that made our modern world possible. Literally every single piece of digital tech you use today, from your big screen TVs to the smartphone in your pocket, traces its roots right back to this simple, elegant system. Pretty wild, right? All right, part 3, making a perfect hundred. So, with our 10 digits locked in, we can start combining them to hit some major milestones. You start seeing these really beautiful patterns emerge when you're trying to hit a solid 100. For instance, taking a block of 70 and adding 30 gets you 100. Same goes for 65 and 35. It's essentially training the brain to see numbers as these flexible, modular building blocks instead of just rigid individual units. Which brings us to part 4, counting real objects. Because, let's be real, math shouldn't just live on a piece of paper, right? The curriculum takes a great turn here by actively grounding these big, abstract numbers in the real world. By having learners look at physical things, like actual boxes of matchsticks or just a handful of seeds, it takes the abstract concept of 100 and puts it literally right into their hands. To make this happen, the chapter outlines this really brilliant, simple 3-step process. Step 1, estimate the objects in your hand. Step 2, count them out exactly. And step 3, compare the two. It's kind of like a mini scientific method. It actively trains your brain to line up those quick visual guesses with exact mathematical reality. And then comes the big challenge, figuring out exactly how many of those handfuls or boxes it actually takes to hit 100. I love this because it forces us to physically experience the weight, the volume, and the actual physical space that the number 100 occupies. It takes 100 from just being a word and turns it into a real, tangible experience. And finally, part 5, reaching the double century. Now we get to push past everything we've learned so far. The ultimate secret to code-a-rank for big numbers is place value. By breaking large numbers down into hundreds, tens, and ones, a previously intimidating number like 152 becomes super easy to digest. 100, 5 tens, 2 ones. You see? The pure logic of those ancient 10 symbols is working its absolute magic right here. And the chapter makes sure to reinforce this from a bunch of different angles. Whether we're jumping along on a number line, calculating that 150 plus 50 is 200, seeing that 140 plus 60 also does the trick, or even just guessing how many times we need to fill a container with seeds to hit 200, the underlying logic is exactly the same. We're really just scaling up the exact same rules we've been practicing all along.
And boom, there we have it. The grand finale, the double century. By breaking the whole journey down, from simple market guesses to structured number grids, the curriculum proves that with just 10 basic symbols, absolutely no number is out of our reach. We've systematically built our way all the way up to 200. So I want to leave you with this thought. The next time you look at a massive crowd of people, or maybe a giant jar of jelly beans at the store, ask yourself, has your inner estimator evolved? Now that you understand the structured logic behind these numbers, just how accurate is your visual math? Thanks so much for joining me on this explainer, and keep calculating.